Now, in maths methods, you have learnt differentiation. What we're going to do here, you will do later in maths methods at the start of year 12. We're going to do differentiating trigonometry. Actually, there's some other things I have to teach you as well later on about integration, which is the opposite of differentiation. But let's start here. This is the graph of sine, y equals sine x. And my question is, what's the gradient? Well, let's start over here. What's the gradient? What's the slope of the graph here? Well, actually, it looks to me like it's going up at 45 degrees. It's going up 1 for every one across. So if the gradient here is 1, let's put a mark at 1. Let's go across to here, pi on 2. What's the slope of the graph here? What's the gradient here? It looks to me like it's flat. And if it's flat here, that means the gradient is 0. So let's put a mark at 0. What about at pi? What's the graph doing here? Well, the gradient here looks to me like it's going the opposite direction from what it was at the start. It looks like it's going down at 45 degrees, which means down 1 for every one across, which is a gradient of -1. Let's put a mark at -1. What's going to happen next? At 3 pi on 2, the gradient here is flat. The slope is flat. That means the gradient is 0. Put a mark at 0. And what's happening over here? We're back to where we started. The gradient is 1 again. Now have a look at those blue marks that I've added. Can I join them in a nice smooth curve? I'm going to try. This might not be quite so smooth as I would like, but it should give you the idea. Now, what graph have I just drawn in blue? That's right, it's cos. The slope of sine is cos. The gradient, or the derivative of sine, is cos. So this is just the same diagram from your textbook. The slope at the start of sine is 1. At 0, the slope is 1. That's here. The slope gradually decreases to 0. The slope becomes -1 here, -1. The slope gradually goes back to 0, 0. And the slope increases up to 1 again. The gradient of sine is equal to cos. Now we can do the same thing with cos x. So, here is a graph of cos x. What's the gradient? What's the slope at each point? If you think you want to have a go before I get there, pause the video and have a look. Okay, let's have a look here. This point, the y-coordinate is 1, but that's not what I'm interested in. What I'm interested in is the slope. The slope here is 0. The slope here is going downwards at -1. What about this one? The slope here is 0. Can you work out what graph this is yet? The slope here is 1. And the slope here is back to flat, or 0. What graph have I got there? Let's see if I can draw it neatly. Or at least neatly enough. So this curve that I've just drawn in red, what is that? It's actually the negative sine curve. The positive sine curve would go up here, back down to 0, -1, back up to 0. Okay, it got a bit messy just down here. But you get the idea. The yellow is the sine curve, so the red is negative sine, which means the slope of cos, the derivative of cos, is negative sine. So here's the same diagram from the textbook. This is a Cos curve. The slope here is 0. The slope here is -1. The slope here is 0. And the slope here is 1. Then we're back to a slope of 0. And the gradient of cos is -sin x.